Let's move on though to gradient. Now, I think out of all of these three, like these two are useful, okay? They're useful in certain situations, but I think this one is probably the most important concept. And in fact, we will meet this again. We will meet this idea again, so it's important to get the idea now. Now, you'll see on your screen, I have drawn 3 points on the board, okay? So, unfortunately, the way which GeoGebra's named them isn't exactly how I would name them. I think it's because I've constructed them in a slightly different order. But effectively, I have got 3 line segments here, okay? Now, what is the difference between all of them? So just talk to me, just say what you see. What distinguishes this line segment to this line segment to this line segment? What do you see? Okay, so length is definitely different. I agree with that. Length is definitely different. Any other differences? Good. So they're all getting steeper, right? So this one is not very steep. This one's a little bit steeper. And then finally, the green line is the steepest of the lot. So I need a way of talking about steepness, okay? And in fact, a special word for steepness is a gradient, okay? So gradient just simply means how steep is my line. Now, obviously, I'm a mathematician, right? I want a way of dealing with steepness in a kind of a measured and calculated way. So rather than just looking at it and saying, oh, this line is clearly steeper than this line, I want to actually give it a number. I want to say, this line has this much steepness. This line has this much steepness, right? So let's think about this. Are you happy that they are all moving the same distance across? Yeah? So they're all moving from this point here to, well, what's the x-coordinate of all these points? 1, right? So they are all moving one step across, one step in a positive x direction. Does that make sense? Okay. But if you have a look, this line segment, which I'm going to call OC, can you see why? Because I'm moving from O to C. Okay. This line segment only moves how many up? 1, right? So this line segment here basically says you move 1 across and 1 up. Okay? So 1 across and 1 up. Okay? What about B? How many do you move up? So you move 1 across, how many up? 2, right? So 1 across and 2. And then what about D? OD? Yep, 1 across and 5 up. Cool. Okay. So I think I'm in a position where I can actually define gradient. Okay? Because can you see with all of these lines, I always move the same distance across. I move 1 distance across, but I just move a different amount up. Just move a different amount up. So the definition of gradient, which I want you to get into your heads, is for every step across. Now, what I mean step across, I need to be careful here, because it's stepping across 1 unit in the x direction. Okay? So for every step of 1 unit in the positive x direction, the way which I'm going to define gradient is just how many I move up by. Okay? It is how many units I move in the y direction. Is that clear? So for every step across, it's how many units I move up or down. Does that make sense? That's all gradient means. Right. So now what I can do then is I can say, well, okay, instead of moving 1 unit across, what happens if I move B to move 2 units across instead? Okay. So what is the gradient of OB now? So I'm no longer moving 1 unit across, I'm moving 2 units across. How can I define this? Any ideas? So now instead of just moving 1 unit across, I'm moving 2 units across. Well, my definition says that it's every step in 1 unit in the positive x direction. So if I move 2 units across, let me draw this. if I'm now moving 2 units across, by the way, how many units am I moving up? 2, aren't I? On the screen, yeah? So I move 2 across and 2 up, okay? Well, my definition says it's every unit 1 across. So if I move 2 across and 2 up, how many will I move up by if I only move 1 across? If I only move 1 across, how many will I move up by?
1.
1, right? So you've got to think, well, okay, everything needs to be in terms of 1 unit across. So what if I did this? What if instead of moving 1 across, I move 3 across? What's the gradient of that line now? It's just 1, right? Because now I'm moving 3 across and 3 up. So therefore, if I only move 1 across, I'm only going to move 1 up. Okay. So what I'm kind of getting at here is it doesn't matter how many I move across by. All I need to do is reduce it so that I only move 1 across. Okay. So I can say, well, gradient then. Now, gradient I usually call little m. Okay. That's just going to be how many do I move up by divided by how many I move across by. Okay. Because if I move 2 across and 2 up, then I'm going to take my y direction, which is 2, and divide it by my x direction, which is 2, and therefore I only move 1 across. Does that make sense? Yeah? Yeah? Okay. So my gradient then is change in y divided by change in x. Okay? If you prefer, you can think of this as how many do I move up by, which is rise, divided by how many I move across by, which is run. Okay? But essentially it's all based around this definition. It's basically saying instead of moving 10 across or 4 across or 3 to the left, it's how many I move across by in the positive x direction. That's the reason why I have to divide by my delta x, by my change in x. By the way, delta here just stands for difference. Okay, it just means change. So as an example then, let's imagine that I have, in fact, what's the first question on that sheet? Can somebody read it out? So what's my A coordinate? 3, 1. Okay. 5, 5. And my B coordinate is 5, 5. Okay. So therefore, if I wanted to actually calculate the gradient of this point, well, my gradient is calculated by change in y. So what's my change in y?
5 minus 1.
Yeah, good. Okay, so I take 5, take away 1, okay?
5 minus 2.
And then 5 minus 3. That's my change in x. So my change in y is 4, my change in x is 2, so therefore my gradient comes out as 2. So what that basically says is that if I only move 1 unit across, I'll move 2 units up. That's that line there. Does that make sense? Yeah. Now you've got to be careful here that you get the order right. Okay, so I said this is point 1 and this is point 2. This is point 2. So in other words, I'm starting off with point 2 and I'm taking away point 1 in the y direction, and I'm doing exactly the same in the x direction. So I'm taking my second x coordinate, which is 5, and I'm taking away my first x coordinate, which is 3. Okay. So I guess another formula for gradient which I could come up with, if I wish, is taking my second y coordinate, taking away my first y coordinate, and doing exactly the same, but this time with the x coordinate. So y2 minus y1 over x2 minus x1. It's really important that you get the order right. So for example, you couldn't swap these two things around, you get a different quantity. Is that clear?